Namaskar everyone, my name is Antriksh Sharma and welcome back to our channel Antriksh and Triyambak. So today's our topic is about hydrogen and its isotopes. Hydrogen is a chemical element with the symbol H and atomic number 1. We have already recalled it in our previous video. In our previous video, we have been seeing that what is our element, atom and molecules. In that only we have also learned how to read the periodic table, and at that time only I have taken that example of hydrogen. So the chemical name of hydrogen is hydrogen only and the chemical symbol is H, atomic number is 1. Now hydrogen is the lightest element, you should all know. The standard condition of hydrogen is gas of the diatomic molecules having the formula H2. Now we'll just see what is the appearance of the hydrogen. Over here, this is a purple glow in the plasmic state of hydrogen. As we have seen that the appearance is the colorless gas, so how can it be purple color? This is because this is not in a gaseous, solid or liquefied state. It is in a plasmic state. In our previous video only, we have seen that there are not 3 states of matter but 4. Solid, liquid, gas and plasmic state. So in the plasmic state only it is of purple color. We have seen that the appearance is the colorless gas. And what is the standard weight? The standard weight convectionally is 1.008. Now next we will see what is a periodic table. Periodic table we have already learned in the last video how to read it. And I have made a just state of mind for it because I want to tell you that here is a helium, here is hydrogen, but nothing is before it. In horizontally there is hydrogen followed by helium, and when we see it vertically it is nothing above the hydrogen and below it is lithium. Now we have seen what is periodic table and state of mind of it. Now let's see what is the atomic number of hydrogen. Before only when we were introducing you with Mr. Hydrogen, we have seen that the atomic number is 1. In our previous video also I have briefed you that what is atomic number. For just a recall, let me remind you what is atomic number. The atomic number or proton number symbolized with capital Z of the English alphabet of chemical element is the number of protons found by the nucleus every atom of the element. Next term is the group. In chemistry, a group, also known as a family, is a column of elements in the periodic table of the chemical element. As we have seen that the first atomic number of hydrogen. Now, same way the group of the hydrogen is also group 1, which is also named as hydrogen and alkene metals. Next term is the periods. A period is a periodic in a periodic table is a row of chemical elements. All elements in a row have the same number of electron shells. Here you can see this is hydrogen. These both are the isotopes, but in hydrogen this is just one shell of the electron and there is just one electron over here. That's why the period is 1 also. So even the period is 1, the atomic number is 1 and even the group is 1. Now the next term is the block. A block of periodic table is a set of elements unified by the atomic orbitals, which is vacancy, electrons and vacancy lies in it. The block number of hydrogen is S, block S. Now next comes is the electron configuration. We all know that there are 4 configurations of electrons. But what is electron configuration? In atomic physics or quantum chemistry, the electron configuration is the distribution of electrons of the atom or molecule or the physical structure in atomic or molecular orbitals. Here are the 4 electron configurations. First is 1s, second is 2p, third is 3d and fourth is 4f. These are the 4 electron configurations, and we have seen that the first one, which is 1s, is the electron configuration of hydrogen. Now electron per shells. Here we have seen this is the electron shell and it is just having one electron in it. So the electron per shell, it would be 1. Now we have seen what is the chemical properties of hydrogen. Now let's see what are the physical properties. Now the phase in which naturally it is present is the gaseous frame. Now next comes the melting point. We all know that the melting point would be of solid to liquid, not with other matters. So the melting point is 13.99 Kelvin and minus 259.16 degrees Celsius minus 434.49 degree Fahrenheit. Now next comes the boiling point of hydrogen. We all know that the liquefied thing would be boiling because we can't boil solids, we can't boil gases, we can't boil plasmas. So the boiling point would be 20.271 Kelvin and minus 252.879 degrees Celsius minus 423.182 degree Fahrenheit. Now next comes the triple point. We all know that what is melting point, what is boiling point, what is a freezing point. But we don't know what is triple point. Let's see what is triple point. In thermodynamics, the triple point of a substance is the temperature and the pressure at which the three phases, gas, liquid, solid, of that substance coexist in a thermodynamic equilibrium. So, what is the triple point of the hydrogen? So, the triple point of hydrogen is 13.8033 Kelvin and 7.041 kilojoules per annum. Next comes the critical point. As we know that we have not knowing much about triple point, same way critical point is something new to us. Critical point is a thermodynamic or a critical state in the end point of a phase atomic curve. Now what is the critical point of hydrogen? The critical point of hydrogen is 32.9838 Kelvin. Next comes the heat of fusion. What is heat of fusion? Atomic fusion of states of substance, also known as the lateral heat fusion, is the change in the atomic resulting from the providing energy, typical heat, to the specific quantity to substance to change its states or to solid to liquid. The constant pressure is remain. So the heat fusion for the hydrogen is 0.117 kilojoules per mole. Next comes the heat vaporization. We have known that what is heat of fusion, but what is heat of vaporization? The atomic vaporization, symbolized as the triangle H vapors, also known as the lateral heat of vaporizing or heat of evaporation. So the heat of vaporization of hydrogen is 0.904 kilojoules per mole. Next comes the molar heat capability. Now, what is molar heat capability? The molar heat capability of chemical substance is the most amount of energy that must be added in the form of heat or moles to the substance in the order to cause the increase of 1 unit in the temperature. So the molar heat capability of hydrogen is 28.836 joules per mole. We have seen what is the chemical property, what is the physical property. Next comes the atomic property. As we know that these elements are being talking about here, so we all know other than the chemical and physical properties, there are atomic properties also. So let's know about them. The first atomic property comes as oxidation state. We all know that oxidation state is an oxidation number in the hypothetical charge of an atom if all our bonds in the different atoms were fully ionic. So the oxidation state is -1, +1 and apathetic oxidate of the hydrogen. Now what is electrorelativity? Electronegativity is symbolized as X, which is a small x of English alphabet, is the tendency of the atom of given chemical element to attract share electrons to electrons density when forming a chemical bond. So the electronegativity of hydrogen is 2.20. Next comes the ionization energies. Now in physics and chemistry, ionizing energy, IE, American English spelling. Ionizing energy is the minimum energy required to remove the most losing bound electrons in the isolated neutron gases, atom or molecule. So the ionizing energy is 132.0 joules per mole. We have seen that what are the chemical, physical and atomic properties. Let's see the other properties of the hydrogen. Other properties also contains the crystal structure. So the crystal structure is the hexagonal form of the hydrogen. Wait, but do you know what is crystal structure? Don't worry. In crystal structurography, a crystal structure is a description of ordered arrangements of atom ions or molecules in the crystallization material. Next is the magnetic ordering. Magnetism is a class of physics attributes that mediated the medical fields. So, magnetic ordering of the hydrogen is diamagnetic. Next comes Cas number. Do you know what is Cas number? Cas registrating number is also referred to as the CASRN or informally Cas number is a unique numerical identification assigned by the Chemical Abstract Service CAS USA to scientific literature. It is including the substances describing from 1957 through the presence of plus some substances from the far back to the early 18th. So the CSS number of hydrogen is 12385-136 133 740 of the H2 chemical reaction. Now next comes that the history. We all know that we have seen all the properties of hydrogen and also seen what is CSS number. Next comes the history of the hydrogen. So history means who has discovered it. So discovery was done by the Henry Cavendish of the hydrogen. And the hydrogen was named, means the chemical name of hydrogen was kept by Anthony Lewis. So we have known what is the discovery, who did the discovery of the hydrogen, who named the hydrogen. Next is the isotopes. Isotopes are the important part of all the elements present in our periodic table. So isotopes are mainly two, deuterium and tritium. Hydrogen is mainly that same hydrogen. So these are these three isotopes which are present. Now what is abundance in these three isotopes? So for the hydrogen it is 99.98%. But for the deuterium it is 0.02%. And the remaining, the trace is of the tritium. So this is the abundance. But do you know what is abundance? In physics, natural abundance, Na, is referred to the abundance of isotopes of a chemical elements of naturally found in a planet. Next comes the half-life. Half-life is symbolized as T-half. Is a lifetime required for the quantity of the reduced half of the initial value. So for the hydrogen and deuterium there is no half time over here present with us. Next is tritium, which is also present, which is 12.321. Next is that what is the decay mode? Like radioactive decay is also known as the nuclear decay. Radioactivity or nuclear designation is a process by which an unstable atomic nucleus loses energy radiation. So for the hydrogen and deuterium, it is stable, but it is not known for the deuterium. Next comes the applications for all the isotopes and even the hydrogens applications. So the hydrogen is used in the petrochemical industries, hydrogen and coolant, energy carriers, semiconductor industries, and rocket propellant. So we have known, I think, all the knowledge which is basic for us to know about hydrogen. So let's go on to the fun fact time. So it is fun fact time. Minorities of universe mass is 75% is comprised of hydrogen. It is most abundant of all chemical elements. So thank you everyone. I hope you have gained more knowledge about hydrogen and also understood how to see the hydrogen's levels. Like first, it was the first element of our elementary table. So we have seen what is the next, and in my next video it would be about helium, which is the next element of our periodic table, which is the second element. And also we'll be seeing the isotopes of helium and what are these chemical properties, physical properties, atomic properties and other properties of helium. And also you have enjoyed today's video and enjoy meeting Mr. Hydrogen. So